Alright, so in the previous video we looked at information leakage attacks. Now let's actually look at some of the ways to actually prevent information leakage. So disclosing system information helps an adversary learn about your site and form a plan of attack, of course. Well, actually sometimes information leakage can reveal extremely sensitive information that can actually be used to continuously compromise the resources or the system at hand. Try to reveal as little as possible about your technology stack, and we've seen how Weaponizer helps in this situation. We've looked into the headers in the previous video, into the response headers, beyond what it is essential for your users to know. So the risk of this attack prevalence is extremely common. I would say exploitability is relatively easy because you only have to read stuff. You don't actually have to exploit anything in most of the situations. And the impact, I would say, it is much more significant than worrying. Revealing system information makes life easier for an attacker and gives them a playbook of vulnerabilities they can probe for. It may not be feasible to completely obscure your technology stack, but some simple steps can go 90% of the way, discouraging most of attackers. Yeah, most of them. Be extra sure to scrub any debug or error information that might reveal what is going on behind the scenes. We've talked about how developers and DevOps should actually make error messages as generic as possible. When a 0-day is discovered, hackers will immediately try to find a way to exploit it. If your site leaks information about the technology you use, you could well become subject to automated attacks. So this is a very important point that we haven't discussed. So let's say, for example, some malicious attackers would use automated tools to read the headers. And if they find certain headers with certain technologies, with certain versions, which are suitable for the vulnerability, they might mount an exploit and actually use that exploit automatically over a large pool of targets. Protection. Disable the server. So how do we protect against information leakage attacks? You should actually, this is what I read in, like I said, 90% of the pen tests. Disable the server header from the HTTP response and similar headers that reveal information about your technology stack. Use clean URLs. So try to use URLs without extensions instead of using PHP, ASP, JSP that actually reveal software information or technology information. Clean URLs. Let's see. Omitting implementation details for the underlying web server. So no extensions. Putting key information in the path of the URLs. This is a clean URL, and this is a specific URL. Clean URLs do not leak server information. They are less fragile since they are explicitly mapped to an underlying resource. So how they're actually, maybe the slow cooker oats is actually mapped to slowcooker.php or ASPX or whatever, or SEO friendly, search engine optimization friendly, or generically more memorable, because you don't actually you don't remember URLs in general, but these are easier to remember than remembering something like this. Now let's go back. Ensure cookie parameters are generic, so don't use JSession ID. Disable, like for example, so that's for Java, but PHP session ID, that's for, I've seen that a lot in PHP, and I'm pretty sure there are many more examples like that, which through the cookies actually reveal the type of technology that you're using. Make sure that there is no client-side error reporting. So you want to disable this in your production environment. Log files and other error reporting systems are useful in your testing environment. When it comes to production, error reporting should be restricted to the server side. And as we've said, make sure that you return generic errors, HTTP 500 for example. Depending on your technology stack, this may require explicitly catching unexpected exceptions thrown while handling web requests. So you might want to probably be catching all the specific exceptions or errors and then map them to a generic response to the client. Sanitize data pass to the client, so pages and AJAX responses only return the data needed. We've seen that in the previous video. Database IDs should be obfuscated if possible. If you retain sensitive data for users, make sure it is only sent to the client side in the context where it is okay to be shared. Like for example, when you're sharing information about the current user. The current user has access to their information, but not, maybe they would have read access to other users' information if you're talking about a social media website, but they shouldn't have access to other users' data if we're talking about a bank application. Obfuscate JavaScript. This will make your pages faster to load, and it will also make it harder for an attacker to probe for client-side vulnerabilities. And as I've explained in the previous video, from an attacker's perspective, there are ways to mitigate this, to actually deobfuscate the JavaScript code and to actually read the clean code that was actually written or wrote by the developers. Sanitize template files, conduct code reviews, and use static analysis tools to make sure sensitive data doesn't end up in comments or that code passed to the client. So before you're actually pushing your code to production, make sure you don't have comments that reveal sensitive information. Ensure correct configuration of your web root directory. This is extremely prevalent right now. We see a lot of configuration files as penetration testers. Even if you just do a Google dorking for a certain configuration file, you can find thousands, if not hundreds of thousands of results revealing sensitive information about different servers on the web. Make sure you strictly separate public and configuration directories and make sure everyone on your team knows the difference. We have code samples. I'm not sure what code samples here, why they would be useful for Django. So configuring the session ID parameter by, in this situation you would try to make the session cookie name as generic as possible. In Ruby, I think it's the same thing. So what they're trying here is making the cookie header as generic as possible. Rails comes packaged with sensible defaults for local test and production environments. So as long as you make sure you're running the correct configuration, error pages should not leak system information in production. So this is for Ruby. Java, obscure the server header by editing the config conf server.xml. So in this situation, we know that there is a server.xml file. If we would be conducting an internet-wide statistic, for example, research, we could look for server.xml and see the prevalence of this as a misconfiguration. Customize the name of your session ID parameter in web.xml. We know that web.xml is a very often used web or configuration file to actually exploit or gain more information about a certain target. Route unexpected errors to a page of your choosing by editing web XML. So unexpected errors here you have. So this is XML based. You route all the errors to a certain location. make sure your custom error pages only disclose detailed error information when it's safe to do so, in non-production environments, of course. If you're using a default servlet, make sure it does not allow directory listing. So I don't even see the point of directory listing, for example, in production environments, unless it is a very specific sort of a situation. .NET. So this actually returns quite a lot of information in the headers. You want to disable the server header and several other headers that leak information. You want to rename the session ID from ASP.NET to whatever generic name. You want to disable debugging information in production. So I've seen a lot of debugging, very explicit and extensive debugging information in production environments. You want to make sure that you edit the web config and contains the following flag: debug equals false compilation debug. You also want to set up your custom error page. Maybe this is not necessary, but you can just write an HTML file with a simple H1 which says 500 server error or something like that. Alright, further reading: how to disable directory listing, security considerations, source code, why is source code disclosure dangerous. This is from Acunetics, this is from Apache Tomcat, this is from NetSparker. Uglify to actually obfuscate.js, closure compiler. So these are resources worth reading. Let's actually see the questions. We have 3 questions. Why would a hacker want to know what web server you're running on? It allows them to research exploits for a particular server version and probe for vulnerabilities. That is correct. They are conducting a survey so they can mock you on social media. Security-wise, why is it a good idea for you to obfuscate your JavaScript code? Obfuscating your code forces users to choose more secure passwords. It prevents the JavaScript from being tampered with on the client side. It can obscure the meaning of the code and the libraries you're using, making it harder, but not impossible, for an attacker to spot vulnerabilities, and it will also run faster. So it's either one of these two, or maybe both. What is a clean URL? A URL does not contain implementation details of the underlying web application. A URL available only over HTTPS, a URL without any curse words, a semantically consistent readable URL that is immediately and intuitively meaningful to non-expert users. This might also be true, but we'll stick to the first one. 1, 2, 3. So all of them were correct. Now going back to the lessons, up next, we're going to talk about password management, and I'm extremely excited about password management as well, the same way I was about information leakage. So let's actually see in the next 2 videos what password management attacks and defenses are all about.